Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem. Just taught myself through attempting to solve the question, and hopefully it'll prove as a useful resource for someone online. So, the problem that I'm going to be doing today is 2974 minimum number game. So I'm just going to quickly read through the description. So, you're given a zero indexed integer array called nums, which has an even length, and there's also an empty array called r. Alice and Bob decide to play a game where in every round they will each make one move. The rules of the game are as follows. Every round Alice will remove the minimum element and then Bob will do the same. Now Bob will append the removed element from array and then Alice will do the same. The game will continue until the nums array is empty. Return the resulting array r. So just looking at this example here, nums is equal to 5, 4, 2, 3. So Alice is going to pick 2, then Bob's going to pick 3, then Bob's going to put in 3 and Alice will put in 2 here. And then the same here, Alice will pick 4, Bob will pick 5, and then the same thing will happen. Bob will put in, Bob will put in Bob will put in 5 and Alice will put in 4. So, I'm just going to go over to my notes. So, I have done this problem, but my camera wasn't on, so I'm just going to have to act like I haven't thought about this problem before. The first thing I will say before going into this is I had a great comment from one of my previous videos saying that going into these problems I should start thinking more about the time complexity of the solutions that I'm writing. Especially with the easy problems, you shouldn't just try and think of a solution that's going to submit. Think of one that's efficient as well. So, although I don't have a lot of experience doing I guess algorithm analysis, just try to think about time complexity when I'm writing like solutions or code or whatever. I'm gonna do my best. I don't think I'll be completely accurate, but going on from this video, I'm gonna try and do that. So please correct me if I'm wrong. So the first thing that I thought of was you're gonna have to find the minimum number. So finding the minimum number, you're gonna have to look through every element, right? So that's O of n. But then you're gonna have to find the minimum element every time. So that's at least O of n. So that'll be O of n times O of n basically, which is O of n squared, which you don't really want. The commenter, it says even with these easy problems, you don't want to be going for like quadratic solutions, quadratic time complexity solutions. You want to try and aim for like O of n or O n log n solutions. Aim for that at first before resulting back to like an O of n squared solution. So the next thing I thought was, okay, I can sort the array nums, and so that would be O n log n, which is far better than this O of n squared. So once I've sorted it, the element at index 0 would always be the minimum element, and then the element at index 1 would always be the second lowest element, right? So that would be Alice and Bob's turn. So Alice goes first. So Alice would be the element at index 0, right? So you would remove the index from remove the element at index 0. Index 0 and put it, we're going to put it in a temporary sort of array, right? Put it in temp array. And then we're going to say Bob would be the element at index 0 again. So we're going to do the same thing. We're going to remove the element at index 0 and put it in temporary array. So all of this is going to be done while list is not empty. So it's going to run O of n over 2, right? That's how many times this is going to run, O of n divided by 2. But I guess you are still iterating over every element. So I'm just gonna put this is O of n. I'm gonna say this is O of n. Okay. So while the list is not empty, it is O of n. And then what we're gonna do is we're gonna take the elements that are in this temp array, and we're going to, once we've done Alice's turn and Bob's turn, we're gonna add Bob's element into R, then Alice's element. And then we're going to return, we're going to turn R. And all of these are like O of 1. Indexing into an array is O of 1. This is O of 1. O of 1. All of these are O of 1 operations, right? And then this is obviously O of 1 as well. So the way that I understand it is you just sort of take the highest order like term. So obviously O of n is worse than O of n log n. So you would say the time complexity of this is, it would just be O of n, right? This is an O of n solution. I might be wrong. Someone please correct me in the comments below, but I think it's O of n. O of n times n log n. Let's go with that. So O of n times n log n. That's going to be the complexity for this solution. And so let's write the code for it. So we're going to go into here. So we're going to forget about this top one. So we're going to sort the array here. So that's what I was going to say. We're forgetting about so that was their first sort of idea, finding the minimum number every time, but that would be too expensive. So we're just going to sort the array first before doing anything. So here we're going to sort the array. So we're going to do like sorted underscore nums is equal to sorted nums. And then we're going to do while sorted underscore nums, while the length of this is not equal to 0. What we're going to do is Alice's num is equal to, and then we're going to remove the element from sorted nums. Okay. And we don't even this temporary now that I'm thinking of it. We could just like put it in a variable. So we're going to do Alice's and Bob's. Sorted nums dot pop. We're going to remove it. Okay. Then what we're going to do is array.append. So then we're going to add in Bob's number. Then we're going to append Alice's number. And then we're going to return array. And just we need to have array defined first. We're going to run. And the test cases pass. Let's submit. And it passes. So thank you very much for watching the video, and thank you very much to the commenter who left a very detailed comment in the previous video, just sort of explaining the whole time complexity thing. I'm going to try and do that going forward because it is kind of like a big thing about like LeetCode and just writing solutions to problems in general. You want them to be efficient, and not, you don't want them just to work. You want them to be efficient too. So I'm going to try and focus on that going forward as well. So thank you very much for the comment. So yeah, I hope this was useful to anyone in some way at all. Just sort of watching someone's thought process behind solving a LeetCode problem. But yeah, I hope this helped you, and I love discussing these problems as well. So if you have any other solutions, please leave a comment below. I love discussing these types of things as well. So yeah, thank you very much for watching the video, and I hope you have a great day. Bye.